Good evening, everyone. Welcome back. I want to talk about your new assignment. We have been working with architectural patterns. Hopefully, all the description from the architecture to the design have been clear, particular Blackboard, model view controller. How to go from block diagrams, this idea of the architecture of any system, to a particular group of classes interconnected, working together with the minimum dependency, solving a problem. Moving that design to source code, and obviously the source code compile and run. Well, with those ideas, I would like to ask you to help me with a new project. Your new project, you should use what we have used previously. I am talking about model view controller. This is the last design that we did. Hopefully now we agree the classes that are involved and what should be a good recommendation for the model, for the view, for the controller. In some place in your source code, and therefore in your diagrams, if you search for a class that is from the API, and that class is some listener, action or mouse, that class, the work of the class should be related with this idea of the controller. The controller should be connected with the view, low dependency, and should be somehow calling actions in the model. Should be the class that make the connection between your options in the view, your widgets, and what the program is going to do. Moreover, the view, if I search for a frame or a panel, somehow they are indicators that around that part of the diagram, the source code, there is the view. And the view is everything that appears on the screen. Dialog boxes, frames, different panels, a combination crazy of widgets that show elements for select actions and elements that show data or what is happening with the data. And finally, my model, everything related with functional requirements, with the actions that the software should do, are going to be there somehow. Those are kind of the three big sections or zones in your diagram, or at least should be. In the model in particular, we talk about there is a lot of things happening there, a lot. One good idea that we described in the previous lecture is, well, inside of the model, you could apply another pattern. One that is common is Blackboard. If you have an application and that application is handling data, the model somehow could be this repository, and the repository have around these elements, the leader, the knowledge, source knowledge, the professor and the students that use that repository to insert data or to get data. Work with that. Moreover, the last thing that we cover is the connection between the model and the view. The model and the view, for sure, they communicate. A good way to communicate them, to keep the independency, the observer pattern, is a common solution. Something in the model is going to be observable, and some panel or some dialog box or widget inside of the view is going to be observing the data in order to show results. You have implemented this several times, assignment 3, assignment 4. One thing that I want to point out, please, if you need to implement observer or observable, you do not need to create those classes. Use the API. It's like if you're going to use a vector or a linked list, You do not create your class vector, linked list, or so on. You did it in some course of data structures. You know how to create those classes. If you're working with Java, you're going to use the ones that are provided in the Java util package, right? There is no reason for reinventing the wheel. You have the classes, you use the classes. Some advantage are in using the API. Use the API. If you're planning to connect a view with a model, use observer and observable from the API. Don't worry for the depreciation message that you're going to get. It is fine. Well, the view, the model, the blackboard. You have this as a guideline of what could be your class diagram. And hopefully after the previous week, you have a clear idea about how to translate these classes, these diagrams, to source code that match one-to-one. There is no different versions of the implementation of this diagram. There is one and only one, and you have the feedback from your project 3 and project 4. Let's do another one. Hopefully this is better than the previous ones. I give you an implementation of the blackboard. Think about these classes inside of this zone, somehow connected there. We reviewed this, previous lectures, classroom. I was thinking about this, having the main. If you think about it here, something in the view, this one was the one with the main. You can make the match. Classroom, the main, if they are the same, and therefore I put them together, all the connections that I have here are really connections that maybe are going to be around this, maybe, or around this. The blackboard. Most important thing with the blackboard, a class that is the repository, students, professors, runnable. We explained this before. The runnable, in the source code that I shared with you, we use threads. We connect everything. You have this class diagram as a reference. This one, together with the previous one, can give you ideas. And the client server. I am not going to ask you to use client server, not yet. The most important thing that I want you to remember is we have an example of client and an example of server. I put everything inside of the main. I do not have diamonds. All my relationships, local variables, look like this. More important, client and server, they are two different applications, two mains. They are two class diagrams. You can put them in the same page, but they are two things. Two class diagrams, two applications, two different representations of things. You can have two model view controllers. You can even have two blackboards. Blackboard for the client, blackboard for the server. Different things happening. Do not forget this part. Now, this is what you know. Again, architecture, design, how to put the design in source code. Moving forward, I want to ask you for an application. An application, model view controller. I want you to use this. I want a blackboard inside of the model, this. Moreover, I shared with you in the previous lecture some ideas about how you can start working. We described the classes for the view. The most important thing, how to split the view and the controller. This class, the classes that have the view, do not have the listeners. This example, the mouse listener, but action listener in the same way should be something here, not with the views. That is maybe one of the main problems or main comments that we made, that the TA or myself did for your assignment 3 and 4. View and controller together. You have source code and you have an idea about how to separate them. So request number 1, separate the view and the controller in your assignment 5. One thing that we're going to review. Second, the connection, observer and observable between the model and the view. Please follow the observer with the API classes to connect the model and the view. Moreover, your project is going to involve processing data. Processing data, I am asking you, please, a repository, and I am going to ask you to have these guys. And those guys are going to be threads. Therefore, runnable, model, view, controller, and the black box. This is the starting point. This is your skeleton for the beta version. The first thing that should work in your application, and I am sure that you already copy-paste the source code that I shared with you, and you have this running. So next steps. For the next steps, I will ask you for the following. Number one, your assignment number 5, minimum requirements, the minimum thing that the TA and myself are expecting. Number one, your project, source code, Java. Your source code should compile and run. Yes, we're going to compile. Yes, we're going to run. Yes, we're going to check that the functionality is there. It's not a lot, right? It's an assignment. It's about software. If we have the expectation that it's going to compile and it's going to run, I think is the minimum thing that you can check. Now, drive, keys, and readability. You have done with this one 3 projects. Previous one, we already talked about readability. We already talked about do not repeat yourselves. We already talked about keep it simple. I am sure that you can apply everything that you have learned here. So compile, run, dry, keep it simple, and easy to read. We are expecting that. Second, I am asking you to submit your source code and also, again, your class diagram. I am asking for the class diagram, not the architecture. Class diagram. Your class diagram, and well, obviously, minimum expectations. Your class diagram match the source code. We have been talking a lot about this. So this time, my expectation is finally, we get source code and class diagram match. They are the same. If you are using association, the code have association. If you have diamonds, the code have composition or aggregation, and so on. They match. Hopefully, finally, the class diagram is not only an adornment, but really the blueprint of the software. That is the main thing. Now, the project is going to be a little bit challenging, maybe. You can work alone, fine. You can work 2 people, or you can work 3 people. The maximum 3 people, and you can make your own team. You select which is going to be your team, which are going to be the friends that are going to be working with you. The only thing, as usual, is a team work assignment. You are working with your team. Now I am giving you the opportunity to select your team. Just be aware. You are a team. You fail or succeed together. It should compile. It's the responsibility of the team to make this compile. Integration testing could be a good idea. Which is the software process that you follow? Up to you. You know Agile, some of you. You want to use waterfall, use waterfall. You want to use prototypes, use prototypes. I am not going to give you recommendations about the process model to apply, but we are expecting something that compile, run, and have all the functionalities. You can work alone, you can work with a team. If you work with a team, just be sure to talk with the people and be sure that you and your teammates agree in whatever is your process model, in whatever expectations you have about having daily meetings or meeting 1 time per week, or start working 1 day before the submission, or start working today. Up to you. Good. Team working, class diagram, source code. The project. Step number 1. Step number one, I am thinking in a project that have the previous design. And now let me tell you the functionality, the requirements. Number one, your project should look like the screen that I am sharing. I am expecting a project that have a frame, is a Java frame, and have a menu bar. The menu bar, just in case, if you need to review a tutorial about how to create menu bars, there is a tutorial. I am expecting a menu bar, and the menu bar have 3 items: file, project, about. 3 elements in the menu bar. Requirement: only you're going to use only Swing, AWT, that's it. No JavaFX or other things. Swing, AWT, that's it, Java. A frame with a menu, step number one. In the menu, this one, the easy one. One option, about, click there, and you open a dialog box. A dialog box with the information of you or you and your team, the about of the project. Easy one. Obviously, I am expecting this to be part of the view. What is the connection between the frame or the class that is implementing frame and this dialog box that is going to appear when I make the click? How is the controller being involved here? Those are the things that I would like to check in your class diagram. There is a class that is related with the dialog box, and there is this class related with the frame. And obviously there is a controller because there is a click in that option. There are at least 3 classes involved in this easy action of click here and show the about. 3 classes, how they are connected. And that connections in the class diagram are really the ones that are in the source code that make this work. We're going to review that. Next, the important ones here, the challenge, is going to be in the menu file and the menu project. And I am going to explain those 2 in the following slides. So menu bar, 3 options, about, easy one, dialog box, information of your team, that's it. File and project as follows. Before starting with the file and the project, do you remember the example that I showed you in the previous lecture? This idea of the panel in which I can make a click and a circle in blue appear? That is what we are going to have in the main area of this application. The frame, the menu, and everything else is this panel in which I can make a click. This is something that is going to be using mouse listener. Yeah, we described that before. And we need also action listeners because the menu, yeah, that is correct. Mouse listener is going to be involved. Action listener is going to be involved. What is going to be the connection between action listener and mouse listener, the interfaces for the API, and one of your classes? One or more, I don't know. Connections, that is what I want. I want to know how do you connect this. Moreover, that your connection match with your code. Anyway, you already have the source code for this. I showed you more or less the description in the previous lecture. You can go back and review. But at the center of this, the JPanel that we created before with the mouse listener, and therefore the mouse listener, the controller that you already have, sending the dots, the X and Y coordinates to the repository, your Blackboard, and visualizing that into the view, the panel as a circle in blue. That part, you already have it. What I want is you to integrate those things that you already have, the diagram and the code, here. Good? So, okay, file and project. For the file and the project, let's review. Number one, the menu file is going to have two options, open and save. Open, you're going to read a file and you're going to put the information of the file in a data structure. Which data structure? Whatever you want to use is your choice. But that data structure is going to be in the Blackboard. From the file to the Blackboard, insert information into the Blackboard. Again, I am thinking about the connections. When I make click in open, that click should be listened by a listener, an action listener. That action listener should call some action in the model and should be the model, some class, some method in the model, the one that read the information from the file and insert the information into the Blackboard, right? I mean, the controller is not going to have a connection with a file reader or something like that. The controller should have a connection with a class into the model. And that class is the one that should do the actions. According with all the things that we have reviewed about information hiding, partitioning, and so on, I want to review what happened with your connections between the menu bar in the view and the controller, and from the controller to something in the model that finally read the data. Similar with save. Save is the opposite action. I have data that I am going to describe to you in a data structure into the Blackboard, and in some point, I am going to ask save is read the data from the data structure and store that data in a file. File reading and then writing. The files, the format, what is the information? I am going to describe that. Now, the files, important things. Number one, the files are going to be text files. Text files, and in particular, I am going to go back to this, the TSP files. You already have this source code. You already did source code for reading these files. I am not asking you to do anything new. It's source code that you already have. My challenge, the reason for asking about this, you already have the functionality. What are you going to do to connect that functionality with the view and the controllers that I am asking you to have as part of the model view controller design? That is really what I want to solve in your code and in your diagram. Now, to make this more clean, if I press open, what I want, as in any other application, is the computer to ask me for the name of a file. In particular, I am asking you to use this, a file chooser. If you never used that one before, here is a tutorial. Moreover, not only the tutorial, but also the source code. You already have the source code for reading the files. I am giving you the source code for the file chooser. And I give you a link for the source code for the menu. And we review the source code for the view and the controller. You have the elements. You have the blocks. My challenge with the assignment, what are you going to do to connect those blocks? How those blocks are going to be connected? And moreover, what is the connection that make a good design? At this point, we have talked a lot about arrows, diamonds, inheritance, and which one is better. At this point, we have talked a lot about the meaning in the diagram of one arrow, one diamond, and so on, and what should be in the source code. You have the elements. Hopefully, you did this before. You can check this, copy, paste, reuse. What are you going to do to put everything together? Number one, to make that something work, obviously. Number two, to make the class diagram match what you have in the source code. or the source code match the diagram, whatever order you follow. But which connections are you going to use? How many diamonds I am going to read in your class diagrams? In which cases you are going to select diamonds or only arrows? It is possible to have only arrows. It's a question for you. It's my challenge for you. We are going to review what I show you as a minimum, the source code, the class diagram, they match. But this is the minimum. The next level is, okay, they match. The design is good or not? Dependency, low or high? A lot of diamonds, black or white? Arrows, inheritance? The rules that we reviewed before. Open and file, open and save, text files, and basically what you already have as the TSP files. In case that you need to remember, these are the files. I am giving you the link again when you can get the files. As a general recommendation, the files are something like this. You can ignore all this, all the things that I put in green. Those are the headers of the files. You can ignore them. What you need to do is to search for this line, the one that begins with the 1. In that point, you start reading. And again, I think you already have this, but just for you to remember, one element, white space, another element, white space, and another element. The first one, a consecutive number starting in 1. The others, X and Y coordinates of a dot. Reading the file. This is the format. Once you have the file, you put these numbers in a data structure, whatever data structure you want. And with that information, as you remember, what we need to do is to put the information on the screen. You already have this, again, in another assignment. You already put dots on the screen. And one thing that I am sure you remember is that in order to put the dots on the screen, you need to make adjustments because, well, remember, these numbers are too big. This number is not exactly an XY coordinate in this screen. My screen in this example is, this is the biggest point. You need to adjust the dots. You already have that method. You already have that functionality. Tell me, where is going to be that functionality? Inside of the Blackboard? Inside of one of the knowledge sources? Inside of the professor? In the view? In the controller? In a class that we already have? In a new class? Are you going to apply another pattern, a design pattern for this? There is any way to make a good design for all the things that should happen here? Because I need to read the data and I need to put the data in the database. Which data I am going to put in the database? The original one? Or something that I could adapt from the original one to the coordinates on the screen? Because remember, the data that you put in the repository is the data that the view is going to be reading. What do you want the view to read? These big numbers or some other numbers that match the size of the screen? And you are giving me ideas, and I think your ideas are moving forward. Drawing panel is something that you have, right? Can you take the drawing panel and all those things that we did before, the things that you already create, and integrate that in the project that I showed you before, in the skeleton that was the skeleton for the application that we created in the previous week? Source code that you already have, plus elements in the library that I am sharing with you, tutorials. You're going to have a bunch of source code. Integration. But the challenge is integration following the best practices. Not only the best practices of programming, the best practices for design. how many classes, how they are connected, all those things that we have been reviewing and hopefully now are more clear than when you did assignment 3 or assignment 4. Read the file. When I click open, put the data in the repository, immediately the data go to the screen. Immediately go to the screen. Okay. Now, the opposite. Option number 1 is I load the data. Option number 2, my mouse is working. I can make a click here, and there is going to be a new dot. And that new dot is going to go to the repository. And maybe another click here, 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 here. My recommendation, work with the small files. I mean, I am showing you here a file with 7,000 points. You can work with the 29, or 50, 40, 10. I open the file, the dots are on the screen. My mouse is still working. I can add more dots. Therefore, makes sense that in some point, I go to File and I click Save. Save. I am going to save all the dots that I have on the screen in a file, in a text file. You do not need to create all the headers that you have in the files that you can get from the internet. The only thing that I am asking you is if I click Save, 2 things. Number 1, again, I need a file chooser. I need the computer to ask me in which folder and what name you want to store your data. File chooser. And then after I use the file chooser, select a folder, provide a name. Okay, what I am going to have is a file with something like this. Only a consecutive number and the 2 coordinates. That's it. Again, it's a very simple functionality. My challenge is, again, you have the view, you have the controller, you have the file chooser, you have some class in the model that is going to do the work, the saving, how they are going to be connected, how many diamonds, how many arrows, inheritance, what is going to happen with the connections. That is the real thing that I want to check in your homework. Obviously, I need this to compile. I need your code clean, and I need your class diagram to match with the code. But that is just the beginning. The challenge, the important thing is your design is good. Can you apply everything that we have reviewed? That is what I am looking forward. Very good question. Here, I am showing you the example with the original numbers. Here, my example is like, I open this one, and when I save, I get this one, because I never change. But very good point. Here, I am okay if instead of the original numbers, you save numbers that are going to go from 0 to 500, like I mentioned before. That is the size of my screen. So if I make save 0 to 500, it is fine. Also, I am fine if these ones are integers, because the pixels on the screen are integers instead of the original floating point numbers. I am okay with that. Again, the connections, the design is going to be the same. If you store in your repository the original data, I am fine with you saving the original data. If you store in the repository the data after you do the adjustment to be the data on the screen, and therefore your repository have numbers 0 to 500, I am okay with you saving that numbers 0 to 500. The original one or the adjusted one, whatever, but save in a file that is a text file and have this format. The sequential number, the X, the space, the Y. Because if I have this format, that means that I can open the file later. I can save a file, and then I can open the file with your application, and it should work, right? If you save the big numbers, they are going to be parsed again, if you store these integer numbers, they are going to be parsed one by one. So I am going to have on the screen exactly the same thing that I say. Good. Okay, open, save the data, mount listeners, action listeners. Good. Step number 2. So far, what I show you is a mixture of things that you already have and things that I shared with you in the previous lecture. Those are your main sources of source code. Put those things together, make a good design. Next. For the next part, the scale is something that you already did. My comment was, from the file, you are going to read these numbers. As you can notice, they are really big. I mean, you have this X coordinate 24,000 and this Y coordinate 51,000, really big. And your screen is only 0 to 500, 0 to 500. So you need to adjust, maybe make a division of these numbers divided by a common constant to adjust the original coordinate to the coordinates in your screen. This is something that you already did in a previous assignment. You go and review that. So maybe this coordinate was this in X and in Y, but on the screen is maybe something more like 500 and 215Y. So you need to transform this to this using a common constant, something like that. That was my comment regarding the adjustment of the dot, the size in the file versus the size that they should have on the screen. Yeah, your open should open these files that are the files from the web, but also the files that you save. They are going to follow the same format, right? Sequential X and Y. So yes, it should work with your files. It should work with the one from the internet. The one from the internet should do the adjustments. The one that you create, you can do the adjustment also. Remember, what is the adjustment? The minimum number, the maximum number, and you map the minimum to 0, the maximum to the size of your screen, both in X and Y. And in order to do that, the only thing that you do is find this minimum and maximum and get this factor that later you use to divide. When you open a file that you create, that factor is going to be 1. So basically it's going to be divided by 1, all the numbers that you save. Those are the two cases. Well, when you save the data, whatever you click is the number X and Y, the most click. So if I make a click here, this one could be 500, 500, more or less. Or if I make a click here, that one is going to be 0, 0. So your clicks are the size of the screen. And obviously, all of this already on the screen have been adjusted. So that's it. Good. You can save this and also this with the new value, adjusted value, or you can adjust the new ones doing the opposite. Instead of a constant for division, a constant for multiplication. Good. Okay, so moving forward, this is open and save, adjustment. Again, it's something that you already have, just put things together. Second thing, I have this menu project. In the menu project, I am asking you to have 3 options. New, run, stop. 3 options. Again, this is the view. The view should notify the controller that you click new, run, or stop, right? We already agree on that. Notification to the controller. The controller should do the following in communication with the model. if I click new, basically what I want is everything go to the initial values. What does it mean? Two things. If you have any thread running, stop and basically kill them. Any process that is running, any thread that is running, kill the process, close the process, stop the process. Bye. And your data structure, any data in the data structure, remove the data, clean the data. If you have a vector or a linked list or whatever, remove all the elements. If you remove all the elements from your data structure, and therefore your view is observing the data structure, you can agree with me that what should happen is immediately everything on the screen is clean. Your screen have nothing. Not because you clean the screen, but because you remove the data from the repository. The view is only a visualization of the repository. So clicking new, kill all the process, empty the data structure. That's it. Good. Run and stop. Talking about threads, when I click run, you're going to start a group of threads, and I am going to talk more about them in the next slides. But run, put your threads to work. Stop. Stop your threads. Stop. Do not kill them. Just stop them. Maybe you can put them to sleep, or you can call stop, whatever implementation you want to use, but run and stop. I can click run, stop, everything froze, and then I can click run again, and my threads continue running. Not from the start, they continue running. They were sleeping, run, continue running. Stop, sleep, run, continue working. And if I click new, everything died. Everything is new. Everything is like I just opened the application. New, kill, run, put to work, stop, put to sleep. Use a TXT file. Answering the question in the chat, save as text file. That's it. And the text file is with the format that I described. Consecutive number, X and Y, using the white space. Good. So, project, new, run, and stop. Easy one, clean everything, kill everything. Run and stop. We need to do something there. Run and stop, go to the controller. The controller need to communicate with something in the model. Something in the model. I am asking you to use Blackboard. And let me be clear. If you're in a classroom and the classroom is full of students and there is one professor, the controller, and there is this place that all of them are observing, the repository, my recommendation, something that you can do is, what if we have a variable place in the whiteboard in which someone, like the controller, put stop, and everyone, like the students watching the whiteboard, the Blackboard, when they read the stop, they stop. You do not need to connect the students or the professors with the controller. Think about it. Could be a lot of arrows. My recommendation, you can connect the controller that is already connected with the Blackboard, because these X and Y's, we already did that. And in the Blackboard, you can put instructions for the students and the professor. Instructions like stop or run. If you're familiar with concurrent programming, if you're familiar with the concept of semaphores, what you can do is to put a semaphore in the Blackboard. Think about this green and red light included in the whiteboard, And basically when the light is red, everyone stop. When the light is green, everyone is working or continue moving, whatever is the concept that you want to map as an analogy. So stop and roll. Now, which are going to be the processes? Well, here I am going to open the options to your knowledge of threads and your creativity. Let's see. Do you remember that basically what we have in the repository is TSP data? We used that data before. You already do this to calculate the distance between the dots. By the way, the dots represent cities. You can calculate the distance between the cities. It's something that you already did from the beginning, from project 1 maybe, or 2. Calculate the distance. Something that you did in the past to calculate the distance, having several dots, is I give you the chance to start in any city. I don't care in which city you start. Remember? Some of you asked me, and I mentioned you can start with the first city in the file. Or you can start with the city that is the first in your screen. I don't care. You calculate the TSP using nearest neighbor. You start in a random point and you calculate things. Your solution was one solution, not exactly the best, because as some of you mentioned, depending on the city in which you start, you can get different results. And probably you can get better results starting here or whatever. Different distances. What if we can create several of these? Remember the knowledge sources? The students. What if in a classroom, someone put on the whiteboard these X and Y coordinates, maybe also the distances from every single city to the others. Remember the matrix? The distance from one city to the others. And what if I ask the students to calculate the tour, to calculate the best tour to connect those cities with the shortest distance? Moreover, what if I ask every single student to calculate this starting in a different city? Okay, if I have 20 cities and I have 20 students, I can ask every of the 20 students to start in a different city, right? And all of them, each of them is going to calculate one, and they can report the result back somehow to the Blackboard. It's like each student calculate the minimum distance starting in a different city, go to the whiteboard, put the result. And in some point, someone, the professor can select which one of all the results have the minimum value, the minimum distance. In other words, the correct answer. And somehow, maybe delete the others, the ones that are not the final result, or maybe highlight somehow the good one. Whatever option you choose, the point is that solution, the one that the professor point out to be the good one, the view is observing. The view can draw that solution. And that is what I am asking you to do. Students calculating solutions, professor pointing out the good one, the view showing the good one, drawing the good one. What is going to be the data structures that you use? You need a linked list for the X and Y's. You're going to need a data structure for the distances of the cities. It could be a good idea to calculate the distance first and having these processes using the distances instead of the X and Y coordinates. It could save time, it could save resources. where are going to report the students the results. There is going to be a stack or a list or something in which each student can report a new result. And then maybe the professor is basically checking that particular data structure. They want to have all the results and somehow moving to the beginning, maybe the good one, kind of do a sorting of the result according with the total distance, or it's going to copy the bad one to a different variable, and that variable is the one that the view is going to be observing. Can you think of all the different possibilities? But the most important thing, the fact that it doesn't matter which option you choose, you can separate what is happening in the model, what is happening in the repository, what the professor is doing, the control, from the view. The only thing that you need to tell the view is what variable inside of the repository you are going to be watching and which one you are going to draw. It's going to be the first element of a list. It's going to be this particular variable that is independent of anything, and the professor is the one that is going to update that variable. I do not know. You tell me. Your challenge. These are threads. There is concurrency. You need to be careful about not having two threads trying to access exactly the same resource at the same time. Good news, the collections that you have in the Java util, they are already synchronized. They offer a save option. If you create something different, you'll be careful. Remember, it's one resource and you are sharing the result with several threads. So what I am going to have is the following. The control, the professor. It could be easy to select one, the best one. Let's make the professor select three, the three best solutions, the shortest ones. Obviously, in some cases, it's going to be only one. But if we have several different solutions, if we put this to run for a while, and in some point I have different solutions, different distances, one better and others that are not so good, let's choose three. Let's keep three available for the view. I have three, and well, inside of the view, what I would like to have is the view to draw those three in different colors. The good one, and I am just choosing these colors, you can choose something different, but is the important one, the correct one, the smallest one in a color that is kind of visible. I choose the red. The second one in a different color, I choose the pink, and the third one in gray. Think about it. In some point, if you put this to run, something that right now is red is going to become pink, is going to become gray, is going to disappear. When new solutions, better solutions are calculated. Your graphical user interface doing this, running, is going to look like something like this. It's going to be working with dots that I read from the files, or I can use click, 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 and project run. And when I click run, these things start working. And in some point, I am going to have something like this on the screen. I want to stop, project stop. I want to do something new, something else, project new. I want to get dots from a file open. I did something interesting, file save, and that file, I can open the file later. And I want to know who did this, about, dialog box with your data. That's it. A lot of elements for the view. I am asking you for a lot of dialog boxes. I am asking you for panels, at least one for sure. I am asking you to remember the drawable area. I am asking you to use the pane component, several different things that we already use. Your view is not going to be only one class. I am asking you to use mouse listeners, and I am asking you to use action listeners, because the menu, because the drawing on the panel, those are going to be part of your controllers. one class, more than one class, I do not know, your choice. And then we have the model. In the model, you're going to have threads, and threads, we already talked about it. Runnable, thread, those classes are going to be involved. Inheritance, association, composition, the repository is going to be there, the Blackboard. How many classes? We're going to have student and professor, more than one class, several classes. They are going to inherit from a common place. What is going to happen with all this transformation of the values that I am reading? Who is going to do that? I don't know why, but I think about the numbers and I am thinking about an adaptation, adapter. The original numbers transform to a new set of numbers. In fact, we did that example. Remember, drawing a circle, drawing a rectangle, and transforming coordinates xy, xy to xy and the sizes? Something similar happening here. And if I decide to use adapter, where is going to be the adapter? Who is going to be connected with the adapter? Obviously, hopefully something in the model or something in the view. Will you put an adapter in the view? Those are the kind of decisions that I expect you to take. And let me be clear, my expectation, guys, I prefer that you send me email, you send emails to the TA from now, tomorrow, any day, asking questions like, I am doing this correctly. This diagram is the good option for this source code. Let us know that you are working. Moreover, if you have questions, ask before the due date. That is the way that you're going to learn and that you can check that you are moving forward, right? Good question. Let's do not do that. Let's make this, when you run the project, you cannot add series. There is no major problem. If you add a series, the threads could continue running, but there is a need for a recalculation. Let's think that you cannot do, should not be able to add series when the project is running. Let's think that in order to add series is before running the project. In fact, you can disable some options in the graphical user interface to avoid the user to do things like open, load, or click on the screen when the project is running. Let's think that the project is running with the series that you have. You can do that. Good? Guys, ask questions before the due date. If you submit without asking questions or without being sure that your solution is the correct one, it's going to happen the same that with assignment 3 and 4. You're going to receive a low grade and then the appeals are going to start. Ask before the due date. Check that step by step, whatever you are doing, source code, diagrams, they are moving forward correctly. We cannot help you with a solution, but for sure, we can check one class versus your diagram, one relationship versus your code. You can share with us small pieces of code and small pictures of your diagram and ask whatever question you have there. Association, composition, relationships. Even about something in the tutorials, how to create a menu, working with threads. I don't know. You have different backgrounds, different experience. Some of you maybe are already familiar with all of this. Some of you will need to read the tutorials. Please do not hesitate to ask questions. The goal is that you learn how to do the architecture, the design, the source code. And again, individual, good. Teams, good. Your choice, but be responsible of your choices. If you're a team, the grade is your grade as a team. So choose carefully. Your project, you have 1 week to work. 1 week. It's all about integration. You can finish 3 days. You have 7 days, a full week. Work on this. Any question, please let us know. Office hours, emails, whatever. Send questions to me or to the TA. 1 week, guys, because remember, you work 10 hours per class. It doesn't matter how many classes you're taking. It doesn't matter what is happening there, 10 hours per class. If any class is using more than 10 hours of your time, talk with your instructor. I think that I am going to use less than 10 hours of your time. Moreover, if you're working in a team, 10 times 3 for this, you already have everything. Do not be worried about the difficulty of this. This is easy. The difficulty is the connections. And my advice for the connections, start working as soon as possible, talk with your team, review the lectures and the source code that you have done before in the projects, the source code that I have shared with you. Step 1 is almost done with the source code that we review in the previous lecture. So I think 1 week is good enough. You choose randomly one, answering the question in the chat. If 2 threads go to the same solution, randomly one, the first one that was calculated, if you are using a stack, for instance, first in, first out. So the first one in, that is, or the second one, if you are using a queue, I am okay with both options. Good. Okay. See you next week. Thank you.